In this problem, we have to find the limit as x approaches infinity of the definite integral from 1 to x of this expression here. Let's go ahead and work through it. So this is the limit as x approaches infinity. And let's go ahead and integrate this. So this first integral here is a formula. It's going to become the inverse hyperbolic sine of t. It's just a formula that gives us this. And then 1 over t gives us the natural log of the absolute value of t. Okay, and then that's the result of the integral. And then we're going from 1 to x. So I'm going to put a value here, t equals 1 to t equals x. These are t values, so I'm emphasizing that we're still evaluating this. So this is the limit as x approaches infinity. Parentheses here. So first we're plugging in x. So this will be inverse hyperbolic sine of x minus, minus. By the way, x here is positive, right? Because we're going from 1 to x and x is approaching infinity. So we don't need the absolute value here anymore. So this is the natural log of x minus parentheses. Now you plug in the 1, sinh inverse of 1 minus the natural log of 1. And the natural log of 1 is 0, so this piece is taken care of. Okay, so what do we do next? Well, we use the definition of sinh. So this is the limit as x approaches infinity. There's our parentheses again. So sinh inverse, rather definition of sinh inverse is the natural log of x plus the square root of x squared plus 1. Then we still have this minus ln x. And then here we have minus sinh inverse of 1. So we basically just plug a 1 into the formula for sinh inverse of x. So it'll be the natural log of 1. And then 1 plus 1 is 2. So 1 plus the square root of 2. All right, let's keep going. This is the limit as x approaches infinity. Now we can use a property of logarithms, right? This is the natural log of a minus the natural log of b, so it becomes the natural log of a over b. It's the quotient rule. So it's just this divided by this. So x plus the square root of x squared plus 1 over x. And then this one here, it's just like a dangling term. I'm just going to leave it because it's a constant. So nothing is going to happen to it as we think about our limit process. It's just going to hang around because it's independent of x. And now let's focus on what is going on inside this first natural log. So for big values of x, so for large x, we have that x plus the square root of x squared plus 1 over x is approximately equal to x plus the square root of x squared. We can ignore the 1, right? Because when x is really big, you square a number and you add 1, it's pretty insignificant. And this is equal to x plus the absolute value of x, that's the definition, over x. But x is big, it's approaching infinity, so x is positive. So that means that the absolute value of x is just x. This is x plus x over x. So this is 2x over x. So this is just 2. So for big values of x, the argument of the logarithm is 2. So as x approaches infinity, this approaches the natural log of 2 minus the natural log of 1 plus the square root of 2. That hangs out. And then using the quotient rule one more time, we have that the final answer is the natural log of 2 over 1 plus the square root of 2. So that would be the final answer. So this limit, this original question, is equal to the natural log of 2 over 1 plus the square root of 2. Make sure that's what we got. Just wrote it down. Yep, that's it. So pretty cool. I hope this video has been helpful to someone out there in the world. Good luck.